So imagine a future where every rocket launch leaving Earth without any toxic residue, where the propulsion is as safe as the water you drink or the air that you breathe. Sounds like science fiction, right? But it's not really, because in our office, where NAMMO office is situated, that's actually what's happening right now. Right now, we are developing Europe's next generation rocket propulsion. And I would like to share with you how we have explored this together with our stakeholders and developed an innovative roll attitude control propulsion system using hydrogen peroxide. And try to share with you some ideas I have about the future and how this propulsion system can hopefully change it a little bit. Yeah, I guess I don't need to introduce myself since you did such a good job, so I'll just carry on. So, for decades, we have had the dominant traditionalists determining how to develop access to space. And for the application that we are aiming towards, which is roll attitude and control, it's been dominated by a toxic chemical called hydrazine. It's extremely toxic for people and for especially fish in the water, etc. And it's extremely costly to handle because of the toxicity. You have to put on evac suits and you have to clear a kilometer of radius to handle the propellant. So we set ourselves a goal to try to change this. How can we do better? And it started actually 15 years ago in a somewhat unlikely place where we bought technology from a Swedish company, because torpedoes has, for the same number of decades, been propelled by hydrogen peroxide. So this is actually where it started out in Rafos in Sweden. But we have not done this by ourselves. With great support from the Norwegian Space Agency, the European Space Agency, and our customers, we have started on a journey which hopefully will provide a cleaner planet. So this is how it looks like. This is the rocket vega-e, which is the end goal of our development. So the RAX system will sit on the upper stage, which is the fourth stage of the rocket vehicle. And it will operate from the moment the rocket leaves Earth until it is in absolute vacuum. And for those that knows a thing or two about how gases operates in high velocities, that's not really easy. Because when the gases accelerate through the nozzle, the gas would like to become as low in pressure as the ambient pressure that surrounds the vehicle. And when it's close to that pressure, the gases separate from where it's contacted, which creates an imbalance in the thrust performance. So this is one example of an extreme case that we need to handle with our propulsion system. But when we're handling liquids like hydrogen peroxide, which is highly reactive, but you don't want it to react before it comes closer to the combustion chamber, right? And since this is a rather new fuel, well, it's not new, since it actually started out in rocket propulsion in the middle of the Second World War. For those of you that are interested in history and rocket history, the V2 rocket was actually propelled with hydrogen peroxide. But for decades, the application has not been materialized in newer space propulsion vehicles. So we couldn't just develop the thruster that delivers the performance. We had to develop all the components. We had to develop a positive expulsion tank, which is a combined pressure vehicle and fuel tank. We had to develop a new welding procedure to join the two half domes together. We had to develop a complete new set of flow control valves to handle the fuel. And we had to develop a thruster, because that did not exist either. So even though the core technology of the propellant is not new, everything that surrounds the performance of this system is new. Actually, also handling this fuel in French Guiana, where the rocket is launched, is also new, even though Soyuz is actually handling hydrogen peroxide as we speak, or not as we speak, until February 22. For CNES, which is the French Space Agency, they had to rethink this and how can they adapt their procedures towards a cleaner, safer propellant to use. So to zoom out a little bit and talk about innovation in a more broader sense, I think wherever you look at innovation or improvements or whatever you call it, you have constraints and you have creativity. I think it's a combination of the two that makes or enables innovation, I would say. And also in our case, it did so because hydrazine is on the REACH list of soon-to-be banned substances. So there needs to be a substitute. But of course, when almost all satellites orbiting Earth includes hydrazine, it will not be banned before there's a replacement, right? Because life on Earth depends on these satellites. So that was maybe not how we started, since we bought it from the Swedes, but I think that's a very nice way of looking at this in terms of innovation and constraints. And I think constraints, in a way, whether it's financial regulatory constraints, environmental constraints, whatever constraint it might be, I think a lot of innovation comes from constraints. I think you have multiple examples of this, and you have probably more than I do, but and it's not necessarily just the idea of hydrogen peroxide, right? The innovation or the improvement needs to be placed into a system, like for instance RAX is. The fuel isn't new, but all the components are new for you to be able to use this fuel. But of course, there are more constraints, as I told you, regarding operational procedures. So in our case, we invited the head of safety in Kourou, Tora Vassbotn, and to teach him about the benefits of this fuel. And he was very skeptical. And we have a rule: when you are attending a course, you have to dip your finger in the rocket fuel, just to get a very human understanding of how safe it is. It looks like water, but a lot of nasty things look like water. And luckily to us, he dipped his finger in the hydrogen peroxide. So I think this paves the way into a better understanding of how to use this. And I think, regardless of what we're talking about, I think collaboration is key. As I told you, we did not do this alone, and I don't think a lot of innovators does what they do alone. So, in our case, the implication of our innovation is, in the end goal is a more environmentally friendly alternative to the existing ones. An added benefit is that we will provide it at lower cost, and it will also be a much lower operational cost for the end customer. And we have actually thought about how could we integrate this propulsion system into satellites as well. Because nowadays, all the satellites are being manufactured one place, they're being shipped to the other side of the Earth, where you have to fill it with hydrazine. But imagine swapping this with hydrogen peroxide. You can actually fuel the satellite in your own production facility and ship it fueled to the launch site, so you only have to pressurize it and launch it. I think that will create an extreme benefit for the customer. So what can you all learn from this case of NAMMO's safer, greener rack system? It's for you to find out, right? Is there any hydrocenes out there in your environment that you want to get rid of? Probably there is. So just find it, find ways to find a better, cheaper, more environmentally friendly solution. And I think my closing remark is really that innovation is not only about new science, right? It's about making existing science more available, more accessible, given the constraints and given the creativity you have in your organization. So yeah, that was really what I had to tell you guys. Hopefully it gave some food for thought. Thank you.